This is our introduction to Chapter 2. In Chapter 2, we're going to be working with a new distribution. So first we're just going to explore the idea a little bit. So in this table, we see the scores and the tallies for those scores. So think scores on a test, and then we're finding out in the tally section how many people earned that score. So in other words, it's the frequency of that score occurring. So first, this is just going to walk us through some things that you can do in your calculator. So if I go into my calculator, and notice it says enter scores in L1, and it tells us how to do that. So if I arrow up, so I'm in L1, and I write in just as it says here. Now this stands for the sequence of numbers. To get to that, I'm going to press second stat. Notice above that it says list. Then I'm going to arrow over to operations. That's what the op stands for. And number 5 has that same sequence going on. So I'm going to press 5. And see down here it tells me I'm looking at my sequence, and I'm going to put in just as it says. So x, comma, x, 34, comma, 20. Oh, I forgot a 34 in there. So I just arrowed back. I'm going to put second, insert, comma there. Then comma, -1. And close my parentheses. Now when I hit enter, this is saying take x, send it to x, start at 34, end at 20, and go down by 1 each time. So when I hit enter, I'm going to start at the number 34, going down by 1, all the way until I hit the number 20. Now yes, you could have just done that by hand, but just some shortcuts that your calculator can do for you. Now you can see I've already entered the tallies into L2 to save some time here. So next it says to enter that tallies in L2. We've done that. Then we're going to set the window ourselves. Now setting the window ourselves is going to set up exactly what our histogram looks like. So I'm going to press the window button, and I'm going to make sure the window reads as this does. So 19 for my minimum. So remember the value here was 20. We're going 19, so it's just barely past it. Our max that we're going to put in is 36. Our X scale is 1, so we're going by ones. Our minimum for a Y is -7. Our max is 22. Notice our highest frequency, the highest tally was 19, so we're just above that. And then our Y scale is 1, X res is 1. So we're going to set the window that way. Next we're going to sketch our histogram. So again, remember in my calculator I press second Y equals. I'm going to hit enter to turn on plot 1. Enter again to make sure it's turned on, arrow down and over to the histogram, hit enter. Now I'm going to have my X list is L1, and my frequency list, since I put in the tallies, my frequency list is L2. So second, number 2 gives me L2. Then see how it's blinking an A? I want to take it off of that. Then I'm going to press graph so it sets according to that window that we set. And we have our histogram, which looks just like this one I've drawn here. Alright, so that's just kind of give you a little bit more into what your calculator can do. Now getting into more of the problems themselves. Asks us to find the mean, the median, and standard deviation. Remember, I can do all of that using one var stats. So again, coming to my calculator, if I press stat, arrow over to calculate, hit enter on one var stats. Now since I have two lists going on, I have L1, which is my list of my data, my X list. Then I have L2 for my frequency list. If you have the newer calculators, the newer operating system, it has it kind of listed out and asks you your X list, and you're going to put L1. Then it asks you for your frequency list. That's when you're going to put in L2. Hit enter, and we get out our one var stats. So we can see from that we have a mean of 27 and a standard deviation of 3.35. And that's looking at the SX since we're taking a sample of data. Again, this will be more important later on. Right now, SX and sigma X aren't that different. It won't be a big change if you use one or the other. So moving on, it says find how many scores fall within one standard deviation. What proportion of the scores is this? So to find what scores fall within one standard deviation, we're just going to take our 27 and we're going to add 3.35 and then we're going to subtract 3.35. So by adding and subtracting it, we find that we have this range from 23.65 to 30.35. If we go back up to our actual data, then starting at 23.65, which would be more than 23, so we'd be starting around here, and we would keep counting all the way until we got to 30.35, so we'd be including 30 in that. If we counted up how many people were in there, we would find that 97 scores are in that area, which gives us 97 out of the total of 142 scores. So that's 68% of our data is within 1 standard deviation of the mean. Next, ask find how many scores fall within 2 standard deviations of the mean. What proportion of the scores is this? Again, going through the same process, we would find 137 scores, which is about 96%. And then finally, if you want to be in the top 20%, what score did you need to receive? Top 20%, we have 142 scores. So 20% of 142 would be 28.4. Then moving down from the top until we get 28.4, we would need at least a 30. So if I move you up here, moving down from the top, if we needed the 28.4 scores, just adding up how many tallies gets us there, it tells us we need at least 30. Now these ideas that we've come to down here is exactly what we're going to be using in our normal distribution. All normal distributions are going to look somewhat like this, where they are mostly symmetric, preferably as symmetric as possible. And then they are always unimodal. It's the bell-shaped curve that you're used to looking at. Within 1 standard deviation will always be 68% of our data, or approximately so. Within 2 standard deviations will be 95% of our data, or approximately so. And then we can always find different percentile rankings. So that's where we're going to go with the next video, moving into actually using the normal distribution.